Hi, this is the final exam review for Math 310. You should have a handout with you that contains all of these problems. Number 1 comes from chapter 14, and it is a sum of cubes. It says factor 8a cubed plus 1. Whenever you see a binomial, something with two terms in it, and you're told to factor it, it can only be one of three things. It can be a sum of cubes, a difference of cubes, or a difference of squares. Anything else, you don't know how to factor unless, for instance, there's a greatest common factor you can pull out. But this is a sum of cubes. It could be written 2 cubed a cubed plus 1 cubed, because 1 cubed is 1. And that could be written as put the 2a in parentheses and cube it all. Now you have it in the form of this formula a cubed plus b cubed. So let's review what the formulas are. When you're trying to figure out what your a cubed plus b cubed formula is, both of your formulas, whether they have the plus or the minus, are going to be a binomial times a trinomial. And they're going to have both terms, and the sign, the operator, is going to be the same as what is in the original binomial. So in this case it would be plus, and in this case it would be minus. So that's the first binomial of your formula. To remember your second one, you're going to have to memorize that it's a squared in front, b squared at the end, and ab in the middle. Not 2ab, but just ab. And that is true of both versions. So now all you need to do is decide what operators to use, plus signs or minus signs. The last operator will always be a plus, so you can just go ahead and write that in. The first operator is going to be the opposite of what's in the binomial. So if you have a plus b, you're going to have a squared minus ab. And in the second one, you're going to have a squared plus ab. So that is an easy way to remember how to write out your formulas and where the pluses and minuses go. Okay, this is 2a cubed plus 1 cubed, so it's a sum of cubes like this, so it's using that formula. So then all you have to do is write, okay, it's the first one, 2a, plus the last one for the binomial, and then for the trinomial, it's going to be 2a, but all of that squared plus, all right, your formula says, or I'm sorry, not plus, but minus. And your formula says that it's going to be a times b, so we have a minus a, which in this case is 2a, times b, which is 1, so we don't even have to write that, plus 1 squared, which is 1. Okay, so now we've written it out according to our formula, and then we just have to simplify. The first binomial is already simplified. The 2a, all of that squared means the 2 is squared, 2 squared is 4, and the a is squared. Okay, and then that is the result. The second problem is a polynomial with 4 terms. When you have 4 terms, you want to see if there's a greatest common factor, which there isn't in here, and then you want to use grouping. Now, in grouping, you always want this middle operator, see how it's a minus? You want it to be a plus. So if you have a minus there, you have to change it to a plus. And the way you can do that is you add a sign, or change the sign right there in front of the 4, and you add a line. So minus 4x is the same thing as plus negative 4x. You have to do that or you will have a sign error. Once you do this, now you can group into something you can factor. So we're going to group the first 2 and the last 2. Now let's look at the first group. The first group, x cubed plus 3x squared, has a common factor, and it's x squared. So when we pull that out, and then we're going to write a parentheses where we're going to put what's left, we have to divide everything by x squared. So the first term, x cubed divided by x squared, is simply x. And the second term, the x squareds cancel, and you're left with 3. Okay, so you want this second parentheses to be x plus 3. You want your binomials to match. So if we take out a negative 4 from negative 4x minus 12, let's write the negative 4 here, and divide everything by negative 4, we're going to have x plus 3, which is what we want. Okay, so now we can take our x plus 3. It is now our greatest common factor. So we can take it from here and here, and these cancel out. And so that leaves you with x squared plus negative 4, which I'll go ahead and write as minus 4. Okay, but you're not done yet, because you have to check to see if you can factor anything out. Now, for a binomial with no exponents and no common factors, that is completed. But look here, there's a binomial, but it's a difference of squares. And when we have a difference of squares, we're going to find the roots of those squares, which are, in this case, x and 2. And then we're going to add them and subtract them. So let's go ahead and write our first binomial, x plus 3. Now, we're going to take these roots, and because it's a difference of squares, x squared is minus 2 squared, we're going to add the roots, and then we're going to subtract the roots. And now we have factored this as far as we can, and here is your final answer. Now let's look at C, which is x to the 5th minus 4x to the 4th plus 3x cubed. This is a trinomial. Our first job in a trinomial is to see if there is any greatest common factor. There is not anything other than 1 for the numbers. But if you look at the variables, we see that we have x's in every place, so there is at least an x common factor. Find the variable with the smallest exponent, which is x cubed. That is going to be your common factor. So we write x cubed down here, and we divide everything by x cubed. And we're left with x squared minus 4x plus 3. Okay, so now we know x cubed is factored, but we have to see if x squared minus 4x plus 3 is factorable. So we need two numbers that multiply to give you 3, this last one, and add to give you negative 4. So those two numbers are going to be negative 3 and negative 1. And so then we bring down our x cubed, and then we write two binomials, and they're simply x minus 3 and x minus 1. And this is the factorization of this problem that had a common factor. In D, we have another trinomial. This one has two variables, x and y, and the leading coefficient has a 16 in front of us. Gee, it would be sure good if we could factor out that 16, because it would be a lot easier to factor, but we can't. Okay, the trick to this one is if you do not notice a pattern of perfect squares, you will have a real bear trying to solve this one. Because if there were no perfect squares involved, you would have to take this 16 and multiply it by 9 to get a big number, and you would have to find two numbers that multiply to that big number and add to 24. Fortunately, we do have perfect squares. 16 is the perfect square of 4, and x squared, the root is x, and 9y squared is the perfect square of 3y. Okay, this is good, but it's not quite good enough. We need to know that this middle term, 24xy, is equal to 2 times 4x times 3y, and here is why. Here is the reason. So the formula we're looking at is a squared plus 2ab plus b squared. This is called a perfect square trinomial. The first and last terms are perfect squares, and the middle term is twice the times the root of each one. So if you have a perfect square trinomial, it factors to a plus b squared. Similarly, if you have a perfect square trinomial that has a minus as its first operator instead of a plus, it simply factors to a minus b squared. So you need to memorize these formulas because they will make your life a lot easier. Okay, here, back to our problem, we have a perfect square do we have a perfect square trinomial? So we know that we have an a squared and a b squared, but do we have a 2 times the first root times the second root? So let's see, 2 times 4x times 3y. Well, 2 times 4 is 8, 8 times 2 is 24, so we have the 24 and the x and the y. So yes, we have a perfect square trinomial. That means that all we have to do is write one binomial, and that binomial is, in this case, since that's a plus, it's the sum of the roots, 4x plus 3y, and it's squared. Okay, don't believe me? Let's check our work. 4x plus 3y squared is the same thing as 4x plus 3y times itself. Oops. Okay, so work your FOIL magic. FOIL is the first term times the first term, and then you add the first term times the outer term. Then you add the product of the middle terms, and then the last term times the last term. 4x, all of that squared is 16x squared. 4x times 3y is 12xy. 3y times 4x is also 12xy. See, there's that 2 times something, and then 3y, all of that squared is 9y squared. So let's add the middle terms, and we see that that matches what we started with, so we did the problem correctly, and this is the answer. It was very easy. We didn't have to go multiplying big numbers together.